Most commonly known use cases for Bluetooth are the speakers, earbuds. Could you share us few examples where Bluetooth is widely used?
Most of the people might not know. There are things like industrial IoT, where Bluetooth is actually extensively used.
Do you have such generations in Bluetooth as well?
We have 5 versions of Bluetooth till now. When Bluetooth just came up, the job was to do short range communication. A new protocol came up, something called as Bluetooth Low Energy, and it actually completely changed the perspective of Bluetooth. Now, Bluetooth is different and Bluetooth Low Energy is different. It focused majorly on.
Can you explain how the devices are communicating?
There are actually two things. One acts as a central and one more acts as a peripheral. This peripheral is the one who is actually sending out this advertisement, and the central is the one who actually initiates the connection.
Can you share frequency range of Bluetooth?
Actually, Bluetooth and Wi-Fi, they both exist in the same spectrum. They actually use the 2.4 gigahertz spectrum. There's obviously a problem, but
Can you walk us through your test setup?
we actually have a Bluetooth traffic generator with us, and we just
Welcome to another episode of Weekly WiFi Wisdom podcast series. I'm Sayanath, your host. I'm a WLAN QA engineer at Candela Technologies, and today we have our guest, Mr. Yaswanth. He has been working at Candela Technologies as wireless systems engineer for about a year now, and today he is here to share all his knowledge about Wi-Fi and Bluetooth coexistence and what are his testing observations from that. Welcome, Yaswanth. I'm glad you are here.
Thanks, Anand. How are you?
Yeah, I'm doing good. How are you doing?
All good, all good. Let's start. I'm just excited to do this.
Yeah, really looking forward to for your insights on this episode.
Yeah, sure.
Yeah, so let's get started. So regarding Bluetooth, right? Most commonly known use cases for Bluetooth for most of the people are it could be speakers or earbuds kind of things, right? But I believe Bluetooth is a very big wireless technology and it touches many use cases. So could you please share us few examples where Bluetooth is widely used but are lesser known to many people?
Yeah. When I also started learning about Bluetooth, and when I got to learn these things about, there are applications not only more than we daily use, something like earbuds and something. I was actually astonished about that too. So for your question, like the applications where most of the people might not know, there are things like industrial IoT, where Bluetooth is actually extensively used, and smart home automation is being actually widely accepting Bluetooth as well, where appliances are actually being controlled by Bluetooth as well, where it also uses Zigbee and something else, but also it uses Bluetooth. This home automations are being used with Bluetooth as well. And to be talking mostly about these things, Bluetooth is actually extensively used in industrial IoT things, where actually machinery of, like, whenever there is an industry, there are actually machines that exist. So these machines are actually needed to, actually they are actually subjected to wear and tear. So what happens there is, to monitor this wear and tear, sensors like machine monitoring sensors or vibration monitoring sensors, temperature, current, voltage, also humidity maybe if there is water or something like that. So in order to monitor metrics like these kind of things, a particular sensor is actually implemented at those machines, and those data are actually transmitted using Bluetooth protocol. There will be a hub sitting somewhere in the warehouse or something like that, and there those data will be metrics that will be passed, and somewhere in the corner of this, I don't know, maybe an industry or something like that, they'll be actually monitoring this data in real time. And one more interesting thing in an application was, there will be warehouses kind of things, where actually there will be a lot of devices, or there will be a lot of trolleys that will be moving around here and there. There is a smart thing called as asset tracking, where small BLE tags or something like that is actually attached on top of an entity. And what happens there is, Bluetooth is able to now track the devices in the warehouse, like where and what it is doing right now, something like that. It can be actually doing those kind of things as well. So these are actually most of the use cases that are actually being implemented right now, apart from the daily that use cases that we actually see, something like earpods or something like that.
Okay, device tracking and then machine
Monitoring systems, yeah, something like that, yeah.
Cool. Well, that's something new for me to know. And Yeah, let's talk. If you look at Wi-Fi, we have generations, right?
Mm-hmm.
We have from Wi-Fi 1 and now
Yeah.
Wi-Fi 7 is also being deployed. Do you have such generations in Bluetooth as well?
Yeah, we do have it. We have 5 versions of Bluetooth right now till now.
Okay, so 5 is the latest?
5 is the latest, yeah. With 5 version 5 is now the latest, which is actually being running at 5.4 currently. Most of the latest earbuds and everything are coming in 5.4 version. Each and every version actually has sub versions in them. Like 1 has 1.1, 1.2, and 3 has 3.0, something like that. And also version 5 has now 5.4. The 5.4 is the latest one. So version 1 came up in late 90s, somewhere around like 99, exactly on 1999. So it was more like a proof of concept more than actual version of it, because Bluetooth just came up at that time. So what happened at that time was, when Bluetooth just came up, it was doing pretty well. Like, the job was to do short range communication with as much as low power consumption as possible, something like that. So it was doing the work, but Bluetooth version 1 actually had interoperability issues. Like, for example, there is a device A and there is a device B. If the device A and B are of different vendors, there were actually communication establishment issues or data transfer issues, something like that. But when both the devices are actually of same vendors, then the communication was smooth.
Okay, so not very reliable if
Yeah.
the devices are cross-platform.
Yes, exactly. More like different vendors, because it has interoperability issues. If at all the both devices are of same vendors, they were actually doing pretty well.
Okay.
Yeah, so that's why version 2 came up. They actually overcame the issue of this interoperability, and also they came up with a new thing called enhanced data rate, where actually the data rate got doubled than the previous one. And also security got introduced in this version. Actually, simple security pairing, like SSP, got introduced in Bluetooth version 2.
So encryption started from version 2?
Yes.
Okay.
Security started from that way, from that version. And then Bluetooth version 3 came. This is actually pretty interesting. So in version 3, they focused on making more data rate. So what they did was, they used an actual Wi-Fi radio. See, this thing came up in somewhere around 2009. Version 3 came up in 2009. So what they did was, they actually able to achieve 24 Mbps of data rate using Bluetooth. But actually what happened behind the scenes was, this connection process and parameters, everything was actually exchanged using Bluetooth. But when it comes to actually transmitting the data, they actually piggyback to the Wi-Fi radio. So for example, if device A and B is there, they both needs to have this Wi-Fi and Bluetooth. Then they will be able to communicate with each other.
So I can only claim a device as a Bluetooth 3 device if it definitely has a Wi-Fi radio.
Yes, exactly. If they have them both, only then it can be done.
If not, it cannot be claimed as a Bluetooth 3.
Yeah, it only goes back, like it backdates itself, and it will use normal version 2 to be more precise.
And on this, so session management and connection establishment and things like that on Bluetooth, and the actual data transfer is on Wi-Fi. Is that right?
Exactly. To be more precise, like Bluetooth will be negotiating a deal, and Wi-Fi will be acting as a payload manager. Like it will be taking the payload, but the actual deal will be making in Bluetooth layers. So that's how it used it to work. It was more like an ad hoc. Like this Wi-Fi link was actually ad hoc mode, point-to-point communication.
Yeah, that's a big jump, I guess. 24 Mbps for Bluetooth.
It was really.
Is there a drawback for having Wi-Fi for better data rates here?
Yeah, there was. Of course, there was a very pretty major drawback. What was? Power consumption. So Bluetooth was meant to have low power consumption and also low data rate. They actually overcame one. They got with high data rate, but they actually drawback in this thing, the power consumption. So they needed a continuous power supply or a more power supply, because they needed to use a Wi-Fi link at that time. So it did not got that much of an attraction, and it was not widespread. Instantly, as I said, version 3 came up in 2009. Instantly the next year, version 4 came up, because version 3 didn't look that much of to a market and it wasn't doing so good. So version 4 came up, and it actually completely changed the perspective of Bluetooth. Version 4 introduced Bluetooth low energy. Bluetooth low energy was such an interesting thing at of that time. So what it introduced was, it focused majorly on low energy consumption and efficiency. So what it introduced for the very first time was, it introduced a new stack for Bluetooth, and a new protocol came up, something called as Bluetooth low energy. Now Bluetooth is different and Bluetooth low energy is different.
So both are two different versions?
Yes.
Okay.
So the previous one is called as classic Bluetooth and this is called as Bluetooth low energy. There's a very tiny difference, also the major thing between them. They actually use two different number of channels and the bandwidth of users of both of them actually different, and the way they also operate is completely different. So Bluetooth version 4 introduced this thing and it completely changed the perspective. And later to that, the current version, Bluetooth version 5 came and it got few more upgrades. Something like 2 megabit phi rate came up. Like previously it had only 1 megabit phi rate in Bluetooth low energy in version 4.
4, okay.
Yeah, in 4. So in what happens in 5 was an enhanced data rate came up, like something like 2 megabits phi rate. So what happens is we have doubled the data rate. And also on top of that, it also got two new data rates. It only had 1 Mbps in the front in version 4. Now it had 2 Mbps as well. And along with that, new data rates came up. Like whatever the data rate was, it was called as coded phi rates. So what they do is they are used for long range communication. So coded phi rate actually has two different phi rates in it. One is 500 kbps and other is 125 kbps. So I'd like to give a pretty small overview on how they work actually.
Yes, please.
Yeah, so what happens here is the coded phi rate actually uses redundant bits. Each bit have multiple redundant bits. So for example, let us talk about this 500 kbps situation. So in 500 kbps data rate, it has one actual bit and one more redundant bit. So in that way, actually, it uses forward error correction so that it can actually be reliable in longer distances. So whenever, let us say, two devices are there, if they are closer in proximity, and if they support all 2 megabits, 1 megabits, and both the coded phi rates, initially they will be connected at 2 megabits. So if their distance is increasing, then it will be having a some kind of agreement. Let us go back to 1 Mbps because I'm not able to hear you properly.
Okay, so they'll drop down the data.
Yeah, exactly. They will be dropping down the phi rates according to the distance or maybe some kind of interference. There might be multiple reasons to that, but let us stick to this one for the simplicity for right now. And if the distance is increasing, they'll be going from 2 Mbps to 1 Mbps, and if it increases more, then it goes to the coded phi rate. What happens here is it will be first going to the 500 kbps where it has one more redundant bit to the actual bit. And if the distance is increased a bit more, it will be using 7 redundant bits for one actual bit. It will be having 8 bits actually.
So you are actually putting 7 redundant bits to isolation just 1 bit.
For an actual bit, yeah.
Okay.
So that's how it makes it more reliable in longer distances.
Okay. For robustness and reliability.
Yes, exactly.
Okay, so this was introduced in Bluetooth 5, right?
Yes, exactly.
And you also mentioned that Bluetooth 4, from there it is being classified as Bluetooth low energy. So since you named it as Bluetooth low energy, may I know what is the typical power level from Bluetooth 4?
Yeah, so they were actually using somewhere around 0 dBm to 4 dBm only. So whenever we've seen devices from version 4, each and every device that are coming out into the market, they're actually ranging from 0 dBm to 4 dBm only. That's around 1 milliwatt to 2.5 milliwatt of TX power. That's it, nothing more than that. That's how the typical range of the TX power ranges and lies in between.
Okay, interesting. So from Bluetooth 4, it switched to low power.
Very low energy, yeah.
Okay, and now you have touched upon this in the initial question. So Bluetooth is being widely used, right? In consumer electronics, if you take be it earphones or speakers. So there are multiple use cases for Bluetooth, right? So can you explain the technology behind how their devices are communicating? Are there any specific kind of frame formats or things like that?
Yeah.
Can you please share?
Sure. So mostly of whichever the device is coming up right now, they're all out of version 5 and they all have both Bluetooth low energy as well as they can actually go back to previous versions as well because they can have
classic Bluetooth for backward compatibility.
Yes, for backward compatibility. Yes, exactly. So so each and everything supports BLE and it can be used for connection establishment and everything. So for the current devices, everything that we have, each and every device needs to be connected or needs to be able to see the other device to just communicate or just to see the other device. So for that, BLE actually uses 4 types of advertisements. There are multiple devices in our environment and each end of them actually behaves in a different way. And for one device to see another device, it needs to be having some kind of an saying it out like, I'm here, are you able to see me, or like, I am here, my name is this, or something like that. Just like we have beacons in Wi-Fi.
Yeah, for discovery.
Yeah, for discovery. We also have advertisements in BLE. So there are actually 4 types of advertisements. As you can see here, the first one is called as scannable and connectable advertisement, and the next one is called directed and connectable, and the next one is scannable and non-connectable, and non-scannable and non-connectable. Before just going directly into this techie details.
Yeah, let me just stop you there.
Yeah, sure.
So, what are these advertisements exactly? So, are these similar to like beacons in Wi-Fi?
Yeah, of course, they are actually similar to beacons in Wi-Fi. Like, there are actually 2 things, like to be device in device topology way. One acts as a central, a device acts as a central, and one more acts as a peripheral. So this peripheral is the one who is actually sending out these advertisements, and the central is the one who actually initiates the connection by seeing out this peripheral. So whichever there is a device that actually advertising, it's actually peripheral. So let us talk in an example. Like for an example, if we have an earpod, right? So this earpod is actually currently a peripheral because it is advertising its presence. Right. And your mobile is a central because it's initiating a connection by connecting that device in the list of the device that actually appears. So in this case, this is a peripheral and this is a central. And to coming to the question, yes, it is exactly similar to beacon in Wi-Fi, where it actually advertises its presence. And these are the types of advertisements that we have.
Yeah.
So let's talk about the example before we going into the techie details. So as I said now, for example, there's a smartwatch or any earbuds. So it will be sending out a scannable and a connectable type of an advertisement. So that in this way, actually, I wanted to clear one thing. Scanning means actually asking out more information that actually is in advertisement. Advertisement has the capability to, piggyback some kind of a data. It has an ability to actually send out data in advertisement itself. It doesn't needs to be connected. It can actually send data using the advertisement. So if a central sees an advertisement and if it needs to be asking what more information do you have, it sends a scan request to the peripheral. So what happens there is, if the peripheral has more data, it will send out a scan response to the central. Yeah. So if it has the data, it will send out the scan response. If it doesn't have, it sends an empty scan response, like it doesn't have anything, or it will just send the advertisement again. So that's how it works. So coming to the first thing, this is how it works. Like the first one, the earbuds and the smartwatch or anything. What happens first is, it will be sending out an ADV IND type of an advertisement. So what it is called, scannable and connectable. Now I can connect to that and I also can scan.
So the first frame is advertisement here?
Yeah, the first frame is actually advertisement.
Okay.
Yeah, if we want to actually do the scan request, because if we want to ask any kind of more of information, we can actually ask that one, or we can actually directly initiate the connection, and the connection will be established.
Okay, so the scan frames are optional.
Optional, obviously optional. If the device if we want to know more capabilities, we need to. If not, we can actually directly initiate the connection. If and only the advertisement is actually connectable. There are actually advertisements which are actually scannable but not connectable.
Oh, so okay. So if the advertisements are only connectable, only then you can send the data.
Yes.
Is that right?
Yes. We can only then initiate the connection.
Okay, probably you will talk about non-connectable.
Yeah, we can. We do have them. So in the next one, we have directed and connectable type of advertisement. So what happens here is, we actually see this in our daily life. Where it actually uses is, let us say if we connect it to an AirPod this day, and if you want to connect it tomorrow as well, like I came now tomorrow. So we have opened this earbud and we just put it aside, and my mobiles now directly connects to it. We don't need to just go back to this list of Bluetooth devices in my mobile and then click back to this one. What happens here is, our mobile will be sending a directed type of thing, or this peripheral will actually send out this directed advertisement. Like the AirPods is actually directly trying to connect to my mobile now. I don't have to like initiate the connection. So what happens here is, this thing will be sending out an ADV direct IND to a specific target, which is my mobile. Okay. And then the connection request will be established.
Right. So
that's how the connection gets.
Remembering the device and establishing the connection from the past known data.
Yes, exactly.
Okay.
So that's how this type of communication established. This is the directed and connectable advertisement. And in the next one, we actually have called a scannable and non-connectable, which we actually discussed earlier. So this is actually used in some kind of things like asset tracking or something like that, because this thing is non-connectable. Like this type of an advertisement is non-connectable. We cannot connect to the peripheral. So let us see an example. Just assume this thing. This is a chair. This chair is actually having a BLE tag, and this BLE tag is going to actually advertise a type of advertisement which is called scannable and non-connectable. So what we can do is, from this advertisement, it will be giving out. Let us say it has some code name of 5. This is chair 5.
Yeah.
From the advertisement, we'll be getting chair 5, chair 5, chair 5, wherever it goes. But if you want to know where are you, if you want to ask where are you, you will be just requesting it. That's like it will be sending the scan request, and as it is scannable but not connectable, it will be sending out the scan response to you. Like it will be saying, here I am with the coordinates. With, let us say, if you have XY coordinates, something programmed to it, it will be sending the XY coordinates to you, but you cannot connect to it.
Okay, so in this case, as I understand it, so it's almost similar to the first one, except removing the connection part.
Yes, exactly.
So whatever data that it sends also, it should be sending in the scan response.
Hmm.
Nothing beyond that. So
Nothing
there is no
beyond.
connection happening.
There is no connection at all.
Okay, so for something predefined information that we need and already configured on the device, we will be fetching it via scan response.
Yes.
From the
Peripheral.
what do you call it?
Peripheral,
Right?
Yeah.
Okay.
This is actually the very greatest advantages of BLE, because you don't need to establish a connection in order to get some information. That's how we can use it. So this is one type of the third type. And in the next one, we actually have non-scannable and non-connectable. With this type of advertisement, you cannot scan it and you cannot connect it. When I got introduced to this thing, I thought, why would it be used?
Exactly, that's what that is what is on my mind.
Yeah, then when I queried about this thing in Google or some search engines, I have found out that these are being implemented in things like prehistoric monuments, museums, or some kind of an exhibition store or something like that. So what happens there is, a BLE beacon thing will be actually implemented at some kind of a portrait like that, maybe. So what happens there is, the portrait will be now sending out beacons, and when the R mobile will come into the proximity of it, it will be showcasing the details of that portrait. For example, if that portrait of some famous personality of history, those details like the person's name, data, and everything will be coming up. And if you move on to the next monument or next image, those details will be coming up to you. So you don't need to scan it, because that's all the information it's already giving up, and you don't need to connect to it. It's pretty much summing up right now, because
but how are you getting this data if you are not doing scan or data establishment?
Yeah, we don't need to scan it, because the beacon, I mean the advertisement of this actually has the data, as I said mentioned before.
Right.
Yeah, so the advertisement contains the ability so that it can actually contain the data in the advertisement.
So the single frame itself has some data.
Yes.
Okay.
The exact symbol. There will be only single way of communication, and that's only does everything.
Right. So you don't actually communicate with the device, but you just take what is there, what info is there.
Yes, exactly. There's only one way.
Oh, nice. So these are the 4 kinds of mechanisms
with the use cases and everything. That's all they do. Like how their devices actually communicate in real life right now. Most of the devices are being actually doing this right now.
Yeah, pretty cool. Okay, now let's get into a little bit technical details.
Yeah, sure.
So can you share what exactly is the operating frequency range of Bluetooth, and probably explain its channel plans, what are the channel widths, things like that.
So actually, Bluetooth and Wi-Fi, they both exist in the same spectrum. They actually use the 2.4 gigahertz spectrum. So I guess we can have a look at the spectrum while talking this. So this is the 2.4 gigahertz spectrum where Wi-Fi's primary channel actually exists, and in the same spectrum, we actually have Bluetooth as well. So this is actually classic Bluetooth, the first one we actually discussed.
Version 3 or below.
Yeah, version 3 or below. Yeah, okay. Of course. So what happens here is, classic Bluetooth actually use 79 channels in the 2.4 gigahertz spectrum, and each and every channel is 1 megahertz wide. So it has 79 channels, that's why. When it comes to the Bluetooth low energy, it's pretty much different, but similar to that. What happens here is, the bandwidth actually got doubled. Now the bandwidth of each channel is 2 megahertz, and the number of channels got reduced to 40 channels. So this is how they exist and how they overlap with each other, the Wi-Fi as well as Bluetooth low energy.
Quick question here.
Yeah.
So if I see the numbering of Bluetooth channels, so I see most of them in sequence, but
Yes.
38 is looking out of place, 37 is looking out of place.
Yeah.
Is there a specific reason why,
Yes,
that is the case?
Yeah, so of course the name is actually weird, like the numbers are actually being placed in a different way. But if we see this channel 37, 38, and if you go to the endest part of this spectrum, the extreme, you can see 39 at of the end.
Yeah,
So
that's also out of place.
yeah. So what happens here is these three channels actually have a specific reason and they have a specific purpose. We talked about advertisements, right?
Yes.
So these advertisements are actually sent in only these three channels from the out of all the 40 channels. Oh, exactly. Yeah.
So within this, what's the width of this channel? It's 2 megahertz.
Everything is 2 megahertz channel. Okay. There's nothing in difference in that.
Okay. And is there any specific reason why specifically the placement of these channels are here?
Yeah, of course there are. If you go back to the extreme left of here, you can see the Wi-Fi channel actually started from this here, and the channel 37 is actually placed away from it.
Right.
So that it cannot have any kind of interference with Wi-Fi or any other protocol existing there. And if you also see the channel 38 there, it also exists between channel 1 and 6, and it does not interfere with Wi-Fi again. And if you go back there, 39, channel 39, it's completely out of spectrum from the normal things. Of course, channel 14 is used in other regions as well, but it does not interfere with most of the regions that actually use Wi-Fi. So that's how they're actually placed, so that it cannot interfere or it cannot get interfered by Wi-Fi itself. Yeah, that was the initial thought of that.
I think they placed it cleverly within the guard bands of Wi-Fi.
That's how actually the spectrum of Bluetooth and Wi-Fi coexist.
Putting the advertising channels aside, I see a lot of channels, data channels. They're actually interfering with Wi-Fi channels.
Yes, they are.
So how big of a problem is that for Wi-Fi?
So there's obviously a problem, but Bluetooth actually uses this mechanism called adaptive frequency hopping. So what it does is, whenever it sees some kind of Wi-Fi activity, and it's, let us say, let us zoom out this thing. If we zoom out this thing, let us see there is Wi-Fi channel 1, 6, and 11 as well.
Yeah.
So if it is seeing a Wi-Fi 20 megahertz channel in channel 1, let us say, it will try to skip these channels in use. Like let us say channel 37 to channel 9, it will be skipping these channels while it's transferring data. So what happens is, if it will be only using these channels from here to here, it will be completely skipping these channels, so that it cannot get interfered by Wi-Fi, and it cannot interfere Wi-Fi. Bluetooth does actually this does this actually clever thing, but from a recent testing experience from ours, when there is a dense environment of Bluetooth, we've seen Wi-Fi get affected. Like it has a pretty much smaller or bigger dips, or some kind of ups and downs in its throughputs or something like that. So there is a chance of getting interference for Wi-Fi, but in most cases, like in single device or 2 or 3 devices of Bluetooth, there won't be much of an effect on Wi-Fi. So that's how it works.
Okay. You talked about Wi-Fi being interfered. So Wi-Fi is a very polite protocol. So it follows something called DCF.
Yes.
And it has mechanisms like energy detect to actually back off from another technologies if they are
Yes.
with a certain power level.
Yes.
Okay.
It does have a threshold so that it can back off.
Yeah. So what are the typical transmit powers of current days Bluetooth devices, and when could they cause interference to Wi-Fi systems in terms of range? Can you
I think
the
answer for this question would be more like proximity. I guess maybe more like not TX power maybe. I guess proximity would be the cause for this. Like for example, if I'm using a device which actually does some kind of a 20 dB, there are actually devices called class 1 Bluetooth devices. They won't be actually they're actually rare. They won't be used in our daily life situations. So let us say if we have a device which actually transmits at 4 dBm or 8 dBm, let us use an 8 dBm example. Let us say if there is a device using 8 dBm TX power, and if it's somewhere far from the Wi-Fi device or something like that, and there is a 4 dB TX power device, and it is closer to the proximity of the Wi-Fi device, then the 4 dB device will be having more effect on Wi-Fi than the 8 dB, because the proximity is more than the actual one. So I don't think the TX power would be causing the scene here, but I guess the proximity. So let us have an example, like let us say we have a TV like this, and we have a speaker just like a Bluetooth speaker just below that, and let us say this TV is actually connected to a Wi-Fi router because this is a smart TV. Let us say this TV is actually connected in the 2.4 GHz spectrum of the Wi-Fi, and also just below it, if there is a speaker and it is also transmitting Bluetooth frames between those things, then there might be an interference between those two devices. So something like that kind of situation.
Since they both are very close to
Yes, exactly. So proximity would be the factor here.
Okay.
Yeah.
Understood. Makes sense.
Yeah.
Yeah. So I think you have pretty much very good insights on all these Bluetooth and Wi-Fi coexistence testing, right? So can you walk us through your test setup?
Yeah.
Give us a brief.
Yeah,
how,
sure.
how do you test actually all these scenarios?
So we actually have a Bluetooth traffic generator with us, which is actually pretty much dynamic. We can actually do things like altering TX powers. We can set from minus 40 dBm to plus 8 dBm of TX powers. We can alter the data rates, which we actually discussed earlier. Like though there are 4 data rates, right? We can use all the 4 data rates. We can alter the TX powers. We can actually select the number of channels which we need to focus on. As we saw the spectrum earlier, we can actually select a particular range of channels, like where we actually need to transmit the data. And we can also do many number of advertisements per second, more than 300 plus per second, because we can actually do this called as virtual Bluetooth interface. So what we can do here is we can actually emulate virtual Bluetooth interfaces where each and every interface will be acting as a real Bluetooth endpoint, and it will be just creating out Bluetooth interference, and we just test out Wi-Fi APs with those things. Everything just exists in a closed RF chamber without external interference, and that's how we actually tested these things.
Yeah. So do you have any insight where Wi-Fi's performance is severely affected due to Bluetooth's activity?
Yes. As I said earlier, we actually tested using our setup, and we actually seen pretty much dips in a Wi-Fi throughput or something like that. So as you can see this result here, we have one. So at the start of this test, we actually started with some 100 Mbps of throughput with a single station. That's it, nothing more than that for a Wi-Fi
throughput, right?
Yeah, this is actually Wi-Fi throughput. Like throughput is on y-axis, and this it's just timestamps on x-axis. So this thing actually started with no interference of Bluetooth at all on Wi-Fi. So this green part, as you can see, the throughput is actually going very calm with no fluctuations or anything. So just when we actually introduced Bluetooth traffic interference, actual Bluetooth traffic interference with just one virtual interface, there actually we can see fluctuations coming up. We actually pretty clearly see those fluctuations. And when we actually introduce one more virtual interference, then the throughput got very steep dip, and it got fluctuated a bit more. And when the third module, like with the third virtual interface, the throughput got very steep. And then we actually just wanted to confirm those things, like if we just stop the throughput, stop BLE interface on one, the throughput got back again, and we have stopped one more, and the throughput got back to the first stage like this one, and we completely stopped the 3 interfaces, then the throughput got back again. So as we can see, there was an effect of Bluetooth on Wi-Fi, and we can actually pretty much see those things and confirm those things from these results actually.
Right. So the modules here, are they indicating, if we take in a realistic scenario, each module indicates one real Bluetooth device?
Yeah, there's actually a catch here, because as I said earlier, normal devices that we actually use, they actually use this adaptive frequency hopping. So whenever there is Wi-Fi, Bluetooth backs off and it doesn't use that spectrum or that specific channels actually. So our test setup, it has a specific thing, like even if there's Wi-Fi, it actually does the traffic, like it doesn't stop when there's Wi-Fi or something like that, because it will be transmitting data in the entire spectrum of Bluetooth regardless of any other interference. So we just wanted to measure how APs or Wi-Fi works when there is interference. So that's how it works.
Okay, so you are forcefully sending the data even there is Wi-Fi activity there.
Yes, exactly.
Got it. And you are seeing severe effect on Wi-Fi's throughput due to Bluetooth.
Yes.
Fascinating. Yeah. On the flip side, do you see Bluetooth's performance getting affected due to Wi-Fi?
Yeah, I guess this is an interesting question. We tried emulating this thing in our labs, but we need a few more observations to confirm this thing, because we've seen packets getting little bit delayed. I don't know because it was because of a terminal, or don't know about the the chipset that we're actually using, but we need to confirm a few things. Until then, that I don't have a say on that thing actually.
Okay.
Because we haven't seen it.
Yeah, I'm curious if you tested this. Since you mentioned that Bluetooth backs off if it detects the Wi-Fi activity. So what if there are Wi-Fi APs sitting on both? I mean, all the three channels: channel 1, channel 6, channel 11. Did you ever test that kind of a scenario?
Yeah. Coming to this part, I would like to add few more bit to the previous question of yours, like Bluetooth getting affected because of Wi-Fi. So let us put in picture of this adaptive frequency hopping. So when we discussed about Wi-Fi spectrum and Bluetooth spectrum as a whole, like we have seen the coexistence, right? So let us say there's a 20 megahertz channel of Wi-Fi, and the Bluetooth was initially transmitting on the entire spectrum by hopping on the entire spectrum. So if a 20 megahertz channel comes up, it will stop using this part of the spectrum. If the 20 megahertz channel of Wi-Fi comes up, then it will be stop using this spectrum, this channels of spectrum. So what happens is 30% of its entire spectrum is being now negated. There is only 60% of spectrum is available for it.
Due to Bluetooth's behavior of adaptive.
Yeah, AFH. Yeah, because of that, 60% of spectrum is only available for it. So if we add one more channel, like as you just said,
Right.
so if we said like if we add one more thing, like one more to 20 megahertz channel, let us assume channel 6. Now it has only 30% available to it. 60% is being consumed by Wi-Fi, and it's only 30 to 40% of left. So theoretically speaking, it will be affecting in protocol level, might not be affecting the user level, because it only uses a very less data rate and use it for normally very less data rate applications or something like that. I guess in protocol level there might be retries, increased latency, and there might be issues rising up in protocol level, but I don't think it will be affecting user that much. But
okay, not pretty much noticeable to the user.
Yeah,
what you're saying.
but answering your question, there will be definitely an effect while speaking theoretically, because the bandwidth of it got reduced, right? Obviously it's going to affect the Bluetooth. Yes, but we need to just confirm it through the results and everything. That would be a really great question. We would like to
I'll be waiting.
Yeah, we would like to test this thing.
Yes. Yeah. So as we know, Wi-Fi is expanding its wings, right? The new spectrum bands actually.
Yeah.
So it few years ago it opened it opened its operations in 6 gigahertz.
Yeah.
And also there is Wi-Fi Halo, which operates in sub 1 gigahertz band.
Yes.
So do you think, given the problems with Bluetooth and Wi-Fi coexisting on the same band, do you think any device operating on 2.4 gigahertz band could take a step back to Wi-Fi Halo?
Oh, that's
to avoid the interference with Bluetooth.
Yeah. That's actually a pretty good question. Yeah, I think we can actually migrate to Wi-Fi Halo. Yeah, because Wi-Fi Halo is actually having a very, very great range. It can go up to 1 kilometers, because obviously because of the working frequency of it. I guess it ranges somewhere around 900 megahertz, something like that. Yeah, so yeah, pretty good question. Yeah, we can actually migrate devices which actually uses less data rate, because obviously I guess the Wi-Fi Halo's data rate is somewhere around 32 Mbps or something like that, because it doesn't have lots of data rate. So devices which doesn't require a lot of data rate, such as cameras, sensors,
right?
Those kind of devices can actually be using this Wi-Fi Halo technology, because if we use this kind in a very large wear area, because it doesn't actually, Wi-Fi Halo also doesn't support mesh topology. It only has star topology. There needs to be a one Wi-Fi Halo hub at somewhere in the center of everything, and all the devices will be communicating using this thing. So you can implement this thing in a wide area for devices such as low energy consumption and low data rate. But I don't think we can use it for consumer things such as our mobiles, laptops.
Why do you think so?
Because as I have seen chipsets and everything, the radio size of this Wi-Fi Halo was a bit bigger than, like, the area of the radio chipset was bigger than the actual Wi-Fi radio we actually use. So I guess there will be size constraints to be implemented in the current, I don't know, maybe what should I call it, current circuitry of mobiles or laptops. I think there would be, because natively I have never seen a single device user device such as laptop or mobile using Wi-Fi Halo. So that would be a new challenge for mobiles or laptops to use this thing. But it would actually do the thing, but I don't think it will be having pretty much data rates, something like that, because there would be lacking.
Right. So there is a compromise on the data if you move to Halo from 2.4 gigahertz.
Exactly. But it would be a really great thing to implement those things, because we will be having Wi-Fi everywhere. We can go in our own street or something like that.
You want longer range with Halo.
But downside is I don't be getting live video streamings of maybe cricket or something like that. Like I should be sitting in my home.
Yeah.
To be getting much data rates for that.
Right. So I think that's a very interesting set of questions and answers that we had.
Yeah.
And yeah, great. I think these are all very good insights, and I have learned obviously certainly new things in Bluetooth. So while this is all good, good to know, I'd like to know, how did you start getting into Bluetooth in the first place? So how did all this happen?
Yeah. So simply the answer for this question would be curiosity would be one thing, and testing requirements would be the another thing, and it just came up and added one on to other. Like one came up with other thing, and the other came up with other thing, and everything just came into pieces at the same time, and we just got interested in Bluetooth as a whole together. It was not only me, it was my team as well. So we thought of just testing how coexistence works with Wi-Fi, because there were many customers that were actually testing coexistence of APs with Zigbee, and we had a customer who actually got requirement with testing Zigbee and Wi-Fi. So we just thought of, why not Bluetooth as well, because they exist on the same spectrum as well. So we just have a thought on how we can create Bluetooth interference, so that we actually got a product regarding that. So we got successful in that part, where we actually created this Bluetooth interference, and then we actually tested out. But we need to have some more few insights and one more testing that you actually said, like how the flip side works, like how Wi-Fi actually affects the Bluetooth. This thing actually we need to test. We need to add it. Thank you so much for this conversation actually.
Yeah, and yeah, the final question, just casual question.
Yeah.
How many months has it been since you are testing this Bluetooth and Wi-Fi coexistence?
Like how many months it has been since I started?
Yes.
This testing?
Yeah.
I guess it would be 4 months from now. Previously, yeah, 4 months. Yeah.
Almost a quarter and a year.
Yeah. It was
awesome.
Yeah.
It was very much nice meeting you, Yaswanth.
You too, Zainab. And thanks for that, tip for us, something like a test case. Yeah.
Yeah, and so that's all, folks, for today's episode. I hope you got some good insights, or at least understanding of how the Bluetooth protocol behaves and the connection establishment happens between two devices. So that's certainly interesting, new for me, to know that there are 4 kinds of variants in Bluetooth connection establishment. I'd like to thank Yaswanth for sharing all his insights. And if you like the video, please share and subscribe. If you have any questions to Yaswanth, please leave them in the comments below. We'll see you guys in the upcoming episode. Thanks for your time. We'll catch you soon. Thank you.